All right. Hi, everyone. I hope you can hear me, see me. If you're here, just give me a sign, write something in the chat, and we'll begin in a second. All right. So, with a couple of minutes after the time, let's start with the topic. So, before we begin, I would love to, if you join via the Slido app, to the interactive poll, so I can test the water a little bit and hear your thoughts. So I will join with you just to make sure that there are no issues there. The code that you have below is simply the passcode that you can use to join. If you have any problems, just let me know in the chat. And yeah, let's just begin. One more thing from my side. Okay, everything is ready. So without further ado, please note it down if you can. Okay, and let's start. So, perfect Python code in an imperfect world, navigating reality with modern tools. So, hi folks, my name is Łukasz Orpik, and in the next 40 minutes or so, I would love to talk to you how to efficiently deliver quality code with Python without losing our heads and sanity in the process. I will start with a bit of theory to give the whole speech more meaning and to give you the motivation to do the hardest part later, making some notes and applying what you find valuable in your daily work. So, a little bit about me. So I work in the industry for a couple of years now. I started my adventure as a C++ backend developer for 5G networks. After that, the life led me to Splunk, where I work right now as Python backend developer for a unified TDR platform, threat detection, investigation, and response. Basically, enterprise security. But what actually might be remotely interesting is why I started the engineering adventure. I hope this was the, I hope. Hopefully this was the motivation also for you. Shortly to the cool stuff, driven by my imagination. I don't know about you folks, but for me still, sometimes what we are doing here seems like pure magic. So I hope you still have this little child in your hearts. Okay, but what actually motivated the speech when it comes to my history actually came before I became an engineer. So I was an acrobat for a couple of years, starting at age 5. And you might ask, why is it important? Okay, so because since I was a kid, I was taught that even in such an ambiguous discipline, when we are mixing dancing and gymnastic skills, there were clear rules. Scoring, for example, feet point, arm straight, and keep up with the music, and we are getting perfect score. So with that mindset in mind, that everything can be calculated, rules are set, we know everything, I was going through my life trying to get as close to the perfection as possible. And with clear rules in our education system, everything seems I don't know, manageable, let's say. If you wanted to get a perfect score, you didn't get it, you just checked what was wrong. There was always an answer sheet that you could just check, and that's it. You took the stuff that you did wrong, you created a plan, you knew what to do, simply just work harder or smarter, and everything was basically unobtainable. So, but with the years coming by and with the uni coming, and especially the classes on optimization, a tough truth about the reality came that perfection in many cases is unobtainable. We don't know a lot beforehand. We have to make a lot of educated guess. And sometimes when we try to get closer and closer, especially with unknown fields to the perfection itself is like a mirage. Basically, we are getting farther and farther away. So, why am I talking about this? You may ask. So, basically, the answer for this question, how all the stories about unobtainable perfection is connected to the code quality, gets answered with the introduction of this programming star, Ward Cunningham. I hope most of you know about him. He's the inventor of the wiki, at least of the concept, co-author of the manifesto for agile software development. Seriously, a legend of programming. He's so well known in the industry that he even motivated was an inspiration for a character in Cyberpunk 2077, Alt Cunningham, which were the best netrunner there. So yeah, you have to be really good to even have characters in video games based on you. Okay, but why am I telling you about him? Because he not only did this stuff, he also coined the term tech debt. Okay, so why, maybe before what it is, I will tell you what was his motivation. So basically, his motivation was to explain to his bosses the need to refactor the financial product they were working on. They were in financial industry, so debt term was well known and to his bosses easily understandable. And how he defined it, basically. Shipping first-time code is like going into a debt. A little debt speeds up the development process so long as it's paid back promptly with a rewrite. The danger occurs when the debt is not repaired. Every minute spent on acquiring code counts as interest on that debt. Okay, so I think that's quite clear. Maybe not so much. I don't know about you, but the metaphor is vivid, and what's important for me, convincing. If I needed to be convinced to spend some money and time on refactor, the debt metaphor would work on me. But as a programmer, I have a little bit of issue with this definition of tech debt. Precisely what exactly is a tech debt? Is all first-time shipped code a tech debt? Okay, I would love to test a little bit of water with you here right now. And if you have your Slido open, I would love to, if you could participate in this next poll. So basically we will play a little game. Is it a tech debt? Maybe I will just jump quickly one more time to this interactive poll, leave it for a couple of seconds for people who would love to join, and we will move back. And in the meantime, I will start the poll. Okay, so basically, we will be faced with one of the questions, tech questions here. This is the example one. And I would love to, if you tell me if it's a tech debt or just a dirty code, what's your understanding here? Yeah, go ahead, and if it's a clean code, just put a clean. And if it's some dirtiness, just send me information. Like, I don't know, redundant ternary, or I don't know, readability issues. One more time code if anybody need it. Okay, maybe I will switch for a second answer here. So dirty code, completely agree. What if 200 will change in the future? Not necessary code, always the truth. I really like this answer. Somebody actually paid a lot of attention here to many things going on in one line. Dirty code, not bad, not bad. To always set to false. Yeah, this one is definitely true. Basically, this piece of code actually does nothing. I would definitely call it a dirty code. Take that depends on the context that we will get soon, but definitely it will cost not only us as a developer, but also will cost us later to refactor this. Yeah, but as it was pointed out here, it's always the truth. It's not necessarily a code. Okay, so let's keeps going. We have two more examples. This one. What do you think, guys? Dirty code, tech debt. What is it? And just to make sure, you should be able right now to answer the example too. Let me verify it. Yep. What's wrong here? Is it dirty? Is it tech debt? I really want to know what's your distinction here. How do you see it? Okay, answers are coming in. 3 more people are typing, so let's just give you a sec. Okay, okay, okay. Okay, so let's check the answers. So, import issues, definitely. We are facing some import issues here. Mainly, we never should nest it in the name, in the method, the self performance. I agree. Magic numbers. Do we have some magic numbers here? No, but this definitely is one of them. Dirty code, clean rows, readable but inconsistent return type. Yeah, I really like this one. Inconsistent return type as well. So I hope, as you can see here, tech debt and dirty codes, there is no clear distinction so far. There are some professionals that spend some time on it, and we will pay attention to it in a second. But from what I would love to, so far, all of these examples are examples from actual code bases. These are examples taken from the daily what the fuck site that I seriously recommend if you have a moment. Basically, people from the industry share anonymized examples of code sometimes and simply have fun. Okay, maybe last one. Maybe, not maybe. This is the last one. Last one. Go ahead, go crazy in here. What would you improve here? The example 3, Polish should be active right now, so definitely join. Getting some answers. Lack of input validation. Max value as a query param. No, take that. Okay, when it comes to the all of these examples, I will show you the outputs here. Some of you are still writing. Then no, take that, lack of input validation. Okay, so far this one I would say is the cleanest, or maybe even the cleanest, but closest maybe to the tech debt, depending on the requirements of our API. Why am I saying that? As you can see, this is the example of an API delivering random number. But the way that we deliver random number is not really random, meaning it's close to one, but for example, if you are delivering these random values for a cryptography industry or scientific industry that needs real random numbers, this is definitely something that we have to fix later on, and this so far can only work as a proof of concept at best. Okay, so enough with examples. Let's see what another hero of our story says about tech debt. So Robert C. Martin, I'm pretty sure that everybody here knows about him. He's another co-author of Manifesto for Agile Software Development. But what's actually crucial, at least for me and to my heart, that he's a big advocate for software craftsmanship. He wrote the legendary book Clean Code, Clean Architecture. So if you didn't have a chance, definitely please take a look at this guy and his work. But what's important here? For him, a mess is not a technical debt. And for him, there should be a clear distinction between messy code produced by people who are ignorant of a good design and a debt. Debt should be reserved for cases when people have made a considerate decision to adopt a design strategy that isn't sustainable in the long term, but short term deliver a benefit. For example, we don't have the time to fix a super important bug right now, so we will put just a warning label. This is an edge case, let's say. Edge case, a poor solution, but it's still better than doing nothing. So yeah, this is something that we will need to fix in another release. But so this is his definition. For me, messy code kind of still is a debt. I mean, let's just look one more time at this example here, at the first one that someone super nicely pointed out that does nothing and only takes our time. This is something that we still have to come back to, we have to fix, and we have to actually figure out how it's supposed to work. So the messy code, for me at least, still works as a metaphor of debt. But I'm not gonna lie, I don't feel nowhere near confident and competent to challenge an opinion of Robert C. Martin. That's why I will use what Martin Fowler said, co-author of the Manifesto for Agile Software Development, another one, amazing, another star of programming. And what did he say? For him, the debt metaphor works well in both cases. The difference is when he says both cases, he means dirty code and tech debt. For him, tech debt works also for a mess that I mentioned before. For him, the difference is in nature of the debt. A mess is a reckless debt, which results in crippling interest payment or a long period of paying down the principal. Okay, he agrees with me. I mean, more likely, I agree with him. But what's more interesting that he actually come up with a way how to systemize it, systemize this knowledge. Basically, Basically, he come up with technical debt quadrant. I don't know about you, but when I first have seen it, first thing that I did, I actually jumped to translator and started translating what actually inadvertent means or prudent. And then actually reading his articles, I had to always have it by my side. I'm not a native speaker, so maybe this is the reason, but for the sake of conversation, let's just use my simplified version of his work. So basically, instead of using deliberate and inadvertent and prudent and reckless, let's simplify it to this form. So the technical debt quadrant, basically how we categorize technical debt, let's just switch it to responsible, irresponsible, intentional, and unintentional. So basically, we can have actions that are intentional and responsible, or responsible and intentional, or irresponsible here on the side. So basically, I hope it's clear, isn't it? Okay, if not, I think it's time for another examples. Okay, and maybe a game. What kind of tech debt is it? So we'll have a couple of examples, for example, for precisely, and I would love to you if you categorize it in the categories: is it responsible, irresponsible, intentional, unintentional? Let's jump for the first example, take a look, and I will activate a poll in the background. And maybe say a couple of more words here. Okay, let me just verify it. The poll should be active for you right now. You have 4 answers here. And basically what we see here, at least, okay, or maybe no. In this one, I would love if you just guess it, categorize it on your own. Is it responsible, irresponsible, intentional, intentional? We had to fix stuff. We had to get some stuff done. I love these answers here. Let me show you, probably you should be able to see it. But yeah, irresponsible and intentional. Intentional, of course, it didn't happen on its own, but it's definitely irresponsible. One thing is to, I don't know, risk stopping in the middle of the road and not causing any harm. Here, especially on the right side here, we are risking lives, not only our lives, but also other participants of the traffic. So this is definitely intentional and irresponsible. Okay, example 2. Let's go ahead. How do you see it? Intentional, unintentional, responsible, irresponsible? Let me just take this to myself, and you are here back with this example. The poll should be active for you right now. Okay, votes are coming. Maybe those, yeah, irresponsible, unintentional. Okay, just a couple more seconds. Okay. Let's check out the votes then. So most of you voted irresponsible and intentional. I actually would argue that these actions are, at least in the comparison to the first one, responsible. Meaning, we are coming back, for example, from holidays. There's no other way to lower the shield. Lower the window of our car door. This is a good temporary solution. We are not risking much here, hopefully. We are definitely not risking anybody's lives, which is good. And we are delivering the short-term solution here. The same goes, let's say, for this air cooling system. Let's imagine we just get stuck in the desert. I would say this is definitely intentional and let's say even responsible. In a worst case scenario, we will get stuck again. So definitely in the comparison, I would say responsible. Okay, let's go with another one to get you a better grip how we can categorize debt. Okay, let me check if I can have the answer for the chat here of the Stream Studio. I just wonder if anybody knows what this building is and why it could be important for this conversation. Okay, in the meantime, I will turn on another poll. What kind of deck that is it? Okay. I don't see many answers here. Okay, then let me jump and say why does it matter. So the building that you see here is actually a city core building, or as you know, city group center, doesn't matter. What actually matters here is that this building actually put at risk thousands and thousands lives in New York City back in the day, right after it was built. And why is it? Why did it happen? The building structural engineer simply forgot to include quartering winds. These are the winds that strike the building diagonally at this corner during the calculations. Okay, this is the one thing, and the building would still withstand this additional load. If not additional engineer decided to replace the welded joints, here you can see them, here, instead of welding these joints, he decided to use the bolts. And this, with wrong calculation, actually meant that when strong winds actually came during the season, this whole building will collapse and kill thousands of people. So, with that in mind, if you didn't jump into conclusion before I gave you the background, let's see the answers here right now. What type of tech debt is it? Yeah, I love the answers here. I love the answers because they are in sync with what I wanted to say. This is highly irresponsible and unintentional. What's actually good that their solution for the problem, how they fix it, was highly responsible. Basically, they coordinated with all the people around, with the weather system, etc., just to solve it over the night. But they were prepared to evacuate everyone. Never mind. Let's jump to last example, which is a good news for people who hate this game and good news for people good news for people that hate this game and not so much for people who love it. So a little bit background here. So back in the day, maybe you know or maybe you don't, but doctors recommended actually smoking cigarettes. They even prescribe it as a solution for being overweight, for being too stressed, for even having a sour throat. They were recommending smoking cigarettes. So back in the day, if you were a mindful person, I don't know, and you had problems with being overweight, you would smoke them. It's what your doctor recommended. This is the best thing that you could have done. No question asked. But later on, after so many years, suddenly you end up with a habit that suddenly is unhealthy, and you have to spend a lot of money, time, effort just to revert it. And actually, it's not an isolated case. There are many cases in our history where doctors were recommending something, and then it was a completely different story. There was action actually in Poland, pij mleko, drink milk, you will be big. And then later on, they actually stopped with this action because they came some research that actually show up connection between drinking a lot of milk, cancer, skin problems. So yeah. Okay, but still, this is the game. What type of debt is it? And let me turn on another last one here, Paul, and let me hear what you think it is. Was it responsible? Your action, meaning you did your best, you listened to the professionals, but you still end up with something that needs to be fixed later on. Was it responsible to listen to the doctors back in the day, or was it not? Is the problem that you end up with intentional? Did you know that you will get it, or was it unintentional? Okay, votes are still coming. A couple more seconds, and we will check the results. Okay, so majority voted responsible and unintentional. I kind of agree here. This is why I put the example here, like this. What can we do if not listen to the professionals around us? And it was definitely unintentional. The problem that we end up with, it wasn't our intention. We weren't aware that such a problem will arise later on. So yeah, thank you guys for voting, for participating, and now let's check where all of these examples ended up. So I hope right now you understand the quadrant a little bit more. And as you can see, we can define all of this as a debt of some kind. If you remember, Uncle Bob actually recommended not to call all of this side a tech debt. He recommended calling it a mess. I, with Martin Fowler, decided, was opting to call it tech debt. But for me, still, it's not enough. I still would love to. I still don't see the value here for calling this tech debt. Let me give you a little bit of background, because right now we are grouping two very different things together. This might not be at all beneficial for our companies. Okay, I will give you an example. Last one, I promise. So, Christmas is soon. So let's just imagine this scenario. All the family together, you talk, gossip, have fun, and casually, out of nowhere, you just say that you took credit. Okay, and what could be the reaction? Granny is super happy because she thinks that you just bought a flat, you found your person, and you start a family for which she was waiting for so long, and she will have this grannies finally to play with. But on the other side of the table is your brother, who, when he has heard that you took a credit, his first thought was that you took the credit from a loan shark to buy a legendary Millennium Falcon set. And soon he will have to help you pay off that pesky loan, or I don't know, risk his younger brother losing kidney. So what I'm trying to say, that all of this is a debt, but context matters. And the question is, even if it makes logical sense, should we use a tech debt for negative cases, let's say the irresponsible ones, and for the responsible ones? Actually, who came up with solution worth knowing is this guy, Doug Norton, author of the Technical Debt Trap, a foundational expression for this talk, actually. Okay, and what actually he proposed is what actually convinced me. He said that all the irresponsible actions, basically the ones to the left here, are technical debt that is nothing but, if we are honest with ourselves, is nothing but a display of irresponsibility here, or what's worse, incompetence. And despite it making logical sense that we should avoid word technical debt for the left side quadrant and simply go with a craft, a trash, basically. This is a jargon word for everything that is leftover, redundant, and getting in the way, craft. If we are taking, if we are caring about our code, this is how we should treat it, as a craft. And as a professionals, we never should deliver anything that could be described as irresponsible and incompetent. Actually, this tech debt we can completely avoid. The other side, however, is a little bit more tricky. Because as you remember, sometimes, let's imagine we get on the right side here, that we are coming back from holidays. This is our only solution sometimes to, I don't know, to roll down the windshield. Sometimes we just have to work with stuff that we have and then work on the fixing plan later on. And the bottom right corner, it was completely unintentional. We didn't expect it at all. So what I'm just trying to say, that the other side actually is something that we have to live in, that we have to live with, because this is part of the real world. This is actually something that we're calling tech debt. And whenever it's located, we have to come up with a remedy plan, put it in a backlog, and work on it. Basically, just to reiterate one more time, at the bottom one, when we are working with the limited information here, we just have to make an educated guess after a proper research and hope for the best. And sometimes we just have to work not with limited resources, knowledge like here, but resources like at the bottom. Okay, so right now we know what is what. So let's just come back to the reason why I talked to you about it. Our developer work is not like aforementioned acrobatics. Sometimes we have to face a lot of unknowns while trying to do the best possible work. There is no clear score. There's no list with all the correct answers, like for example here for these cases, or unlimited resources like here. We just have to live with that situation. But for the left quadrant, there never should be a consent. We should never ask ourselves whether or not we should do the job right way. Let's imagine if it was working like this for other industries. For example, the doctor has a big queue, so he will just do a half-ass job. And he will be like, I will fix it later when I will have time. No, the same goes with constructions. We are professionals, and code that is irresponsible, or work that we deliver cannot be irresponsible or incompetent, or at least I don't want my work to be like that. So the title of this presentation was a perfect Python code in the imperfect world. And after this little theory, I would love for you to just know that when I mean perfect code, is a craft-free code. And basically all of this introduction was made to convince you to the hardest job right now, hardest part, meaning take some notes for what comes after and apply for what you find useful later on in your day-to-day job. Job, work, passion projects. So perfect code is craftless code. So how can we achieve it? What are the anti-craft strategies? Basically, there are two. We can go with the cleaning iterations, meaning basically in one sprint or in one period, we are just developing, adding new features, and then we spend some time cleaning it. What I should actually tell you about is what is this chart here to the right side. So this is part of research included also in Doug Norton's speech, which analyzed projects, two approaches: this cleaning iteration and constantly cleaning. Here on the vertical axis, we have cost of cost of change, and here we have time. And and the black line here is no cleaning at all. And what you can see here is that with cleaning iterations, we are fixing stuff only temporary. And soon the cost of change is basically equal to the same as we are not cleaning at all. So our only solution here is constantly cleaning and following a rule that I hope you know, which is Boy Scout rule. So basically leaving the campsite better than it was before. It also is great because the code that you as a developer work on, the code that is most worked on and could take more time from everybody else is the cleanest. Because every time someone is making a change, he's improving the code quality. So if constantly cleaning is our only solution here, what are, let's say, his anti-craft weapons? So we have to clean constantly. This is the study reality, and how we can do it efficiently without losing our sanity, heads. So first thing, static and dynamic tools. I will touch a little bit upon it in just a second. And then paying close attention to the metrics like coverage, complexity, coupling, maintainability. And when it comes to these metrics, following the trends, not aiming for a lofty goals like 100% of coverage, because that way we can up with artifacts, let's say, that doesn't provide any value for our company, doesn't provide any value for our project. They are just here to improve the statistic, but actually don't test much. And last but not least, learn constantly. And that said, let's move with that one. What I mean by that, let's learn a bit. Let's start with Python, and then let's move a little bit to tooling. I would love for you to leave with something valuable here, not only lofty theory. So, Python. This is why we are here. This is PyTech after all. My favorite modern Python capabilities that increases readability and code robustness right now is related to the core characteristic of the Python, meaning to his typing style, as you can see it. As we all know, Python is dynamically typed, precisely duck-typed, meaning type of an object is determined by its behavior at runtime. Everybody knows that, hopefully, that is here present. But as you know, probably this is a double-edged sword, meaning it improves code speed. Development process is much more faster, especially with a hobbyist project. Most probably this is why we all were attracted to Python in the first place. But it's also, this typing type is also error prone and harder to debug and read, especially in complex systems. That's why, as a professionals, after all, that deliver perfect code in an imperfect world, meaning craft-free, we have to find a middle ground here. And I would love to show you a couple of ways how to achieve it. We have mainly four tools. Like Pydantic, data classes, type, name, tuple. No worries, we'll just jump right now into details. We'll start with Pydantic. Pydantic is third-party library focused on data validation and parsing. It uses Python data hymns just like data class, but adds a lot more power under the hood. So, as you can see, the basic example, it's nothing complicated. The readability issue starts here when we add additional requirements. So I would recommend not to use it all the time. Use it, for example, for validating unvalidated data. For example, when we are getting stuff from the user, validated with the Pydantic, and then use other tools that I will mention later on, because it's not only we are losing readability here a bit, but Pydantic also has some performance overhead. After all, we are performing additional actions. Performance was improved with later versions, but still, this is something that is worth paying attention to. What pros I might have not mentioned? Runtime validation. Oh, this is the important part when it comes to Pydantic, as this is the only tool that I mentioned. That I have runtime validation, meaning it will raise an easy to debug error during the runtime when we receive improper types. This is super crucial. That's why when you're dealing with unvalidated data that you don't trust, use Pydantic. Another tool, TypeDic. Pros, built-in, minimal overhead, static type checking. So it gives dictionary structure, so your IDE and static analyzer can understand them. This is tool mainly for you, but it's great at consuming external JSON contracts, like we can see here. This is just a dummy example, of course, but it's a great usage of TypeDic. Thanks to this, we are getting a lot of useful type hints later on in the IDE. So cons, as I mentioned before, only Pydantic has runtime validation. TypeDic has nothing like this, but it adds this type checking, and for consuming external JSON context, it's perfect. Then we have named tuple. This is additional tool in our toolbox. And what we have here, of course, no runtime validation, as I said before. This is what Pydantic only offers, but it has minimal overhead. It's lightweight, it's built-in, it's immutable, and it offers still type hints. So it improves readability, improves development speed. So if you work with any configs in your system or stuff that don't change, constants, named tuple is a great tool here. Okay, another one, data classes. So pros, it's built in, it has clean syntax, it's depends on the setup, it's mutable or immutable, and it's rich in features. Okay, so basic examples, as you can see, only thing that you have to add is this decorator. So as you can see, it's very clean and also rich in features. For example, we can pass this default factory here, which is kind of crucial because when defining a data class, you might want to use a mutable default value, such as list of dictionary that we have, for example, here. If we didn't use the default factory, we would risk unexpected behaviors, the way that default arguments would be shared between across instances. But it also allows us to do tricks like this without constructors. So still keeping a super clean syntax. Okay, so I mentioned 4 tools. I wouldn't be surprised if you didn't remember them all. So as I mentioned before, hardest part right now, take a screenshot right now just to remember what's what and what to use in your projects, either passionate or maybe adding it to your work. So Pydantic, this is when you're interacting with the end user. You have runtime validation, but you're facing overhead. TypeDic, great for consuming external JSONs. It has minimal overhead, but offers only static type checking in your IDE. Name tuples, config, not rich in functionality, but it's immutable and offers minimal overhead. Data classes, super readability, clean syntax, moderate overhead. So we also could use some advanced patterns here, like combining data class with TypeDic. Here we have example of loading database settings from a JSON. As you can see here, we are using TypeDic, so consuming basically external JSON. And then we are using it to initiate a data class with additional method. Okay. Then we have pydantic data classes. This is, let's say, another advanced pattern. Basically, what it is pydantic way of providing runtime validation while still being super close to this vanilla experience of data class, built-in data class that I mentioned before. We are, if I'm not wrong, slowly running out of time, so I will just jump ahead. And let's, as I mentioned before, we have not only learning here, it's not our only anti-craft weapon, we also have tools here. Tools like formatters, linters, static code analysis tool, test. I hope you know all of them and you use most of them. But just to recap and to systemize our knowledge, formatters automatically standardize code style, linters check for style issues, but patterns, unused code, simple bugs, and static code analysis tools, deeper analysis than linters, can detect smells, complexity issues, security. For example, Radon is great for following complexity bandit, security issues. But there are also tools like SonarQube that basically deliver more richer feedback. Quick question, I didn't add it as a poll, but it's worth knowing what's different between linters and static code analysis tools. I'm talking to the editor here right now, unfortunately, due to the time constraints, but basically all the linters are static code analyzers, but not the other way around. Not all static code analyzers are linters. This is why I split them a bit, because, for example, MyPy can be defined as a linter as well. Then we have, of course, tests. Because this is worth paying attention to, as I said, metrics. Because good tests actually give you the capability to fight with the craft that actually exists there before. And metrics. PyTest, unit coverage. Then we have code reviews. This is also important. Start with AI-driven. GitLab and GitHub offer even free tiers for educational licenses. And automation, pipelines, and hooks. And what I would love you to be, it's not to be afraid of trying it, even in your personal projects. Every time you start your new project, try to add one more tool, test it. Actually, I had planned to show you usage of one of the tools, SonarQube, at least locally, but I think due to time constraints, because it's a little bit longer demo, we will just jump ahead to the little summary. Okay, maybe here. This is basically, I will finish here. This may be a little bit of a reiteration of what Don Norton said. As a professionals, never ask if you should do the job right. Just do it right. Today, with the rich set of tools that you have seen before that I show you, it's not super hard. It just requires paying attention, and it will benefit you in the long time and in the long term. So yeah, that said, I wanted to say thank you. Thank you for paying attention. I hope that this presentation was valuable to you, but don't leave yet. There's a quick Q&A session, but before that, I have another QR code for you to scan. As you know, Splunk is the sponsor of the PyTech, and we organized a contest, live contest. Basically, we are testing the knowledge about Python. 5 questions, if I'm not wrong. 2 of them, getting 2 right is enough to participate in the lottery. And what are the rewards? Maybe maybe your dream Lego set. Who knows? There are a couple of them in the rewards pool. So scan it, fight for it, and I wish you all the best luck. And again, never ask if you should do the job right, And with the tools that I presented, I hope you will work every day on delivering the perfect code. So yeah. One more thing. If you have a time, please check a sponsorship tab of Splunk. There we have a couple more links. There are 2 more meetings if you are interested in the career in Python in Splunk, or just simply want to reach out. Yeah. Thank you guys. Now Q&A session. Do we have any question? Okay. Pytanie z maila. Okay, from mail. Does the modern Python ecosystem, RAV, MyPy, Python classes, Python actually reduce technical debt, or does it just to postpone it? How does it look in the real world project? Okay, I wouldn't say it postpone it. In the real world project, it basically technical debt. Oh, okay, I have to focus on this part. These tools don't reduce technical debt, at least in the context that I presented it. It reduces the craft. These are the anti-craft tools that you remembered, hopefully. These tools help to fight with craft. It doesn't reduce technical debt. Actually, these tools help not to introduce craft to our code bases. Tech debt will still be introduced because, as you remember, this is something that is either unintentional and it's hard to detect, and for example, follows our best understanding right now, or it's a conscious decision. This is something that tools will not stop. The tools that I presented will stop craft. And as I said before, this is the best we can hope right now. Yeah, we cannot predict the future. Okay, do we have another question? Okay. From mail again, where, in your opinion, is the practical boundary beyond which Python stops being a good choice as a core language? I have some experience, as you know, with C++ and Python. Boundary beyond which Python stops being a good choice as a core language. I would say it depends highly on the discipline, and it also depends on the team members that you have to work with. I don't have enough knowledge right now to make super educated answer here. There are a lot more professionals who could deliver much richer and valuable answer when it comes to choosing a code language for a project. But from what my side I can say is the Python stops being a good choice when we don't have a need to leverage all of this rich environment that Python offers, all of these rich libraries. I would say, and when we don't have a team that is a proficient in it. For example, for me, Python stops being a good choice as a core language when we have to work on a project as a team, and all of the team members currently are specialists in, let's say, C#. But when it comes to choosing Python as a core language in a fresh project without team members, I would say there are much more resources to get better answer than mine, but mine is currently if the project doesn't require using all of the feature of Pythons and rich libraries. Yeah, because currently, as you might know, we are getting better and better at speeds. So this argument is losing its ground finally. Okay, do we have another one? is from Facebook. In long-lived systems, where code is written by generation of developers, what is the bigger challenge? Maintaining Python's readability or maintaining the consistency of its tool ecosystem? Or maintaining the... Okay. But what is the bigger challenge? Maintaining Python's readability or maintaining the consistency of its ecosystem? I would say that it depends on the culture, but when it comes to maintaining Python's readability, I don't see it much of a challenge if we follow this Boy Scout rule, that one I mentioned. The crucial part of the code base will be continuously worked on. By other developers. So with time, the most crucial parts will be kept up to date. Okay, and when it comes to maintaining the consistency of its tool ecosystem, I would say this could be a challenging part. I would say this one, maintaining consistency of its tool ecosystem, this would be the bigger challenge, because sometimes sometimes using the newest tools requires different Python versions. And as we all know, in big projects, updating language versions can be actually challenging. We had actually this issue back in the day in C++, in the BTS station in 5G networks, where I worked there for 3 years, and I think one of the updates still wasn't completed back then. But yeah, just one of the stories. In general, maintaining consistency of its tool ecosystem takes a long time and requires additional effort, and maintaining Python's readability could be described as just a part of the process of good practices. Okay, do we have another one? Okay, so this is the last second to ask any questions. So if nothing will come, I would just jump one more time maybe to this link. Please scan to win, join our live contest if you didn't. As we all hope to hear or aiming for, we are Python specialist or aiming to be one. So test your knowledge, and yeah, let's see. I wish you all the best. How much time do we have? Okay, we are over time. So thank you all. And I hope to see you in real life, maybe in another conference. Have a productive day, and I wish you many successes in your work and in your regular life. Yeah, have a nice day, everyone.